this is in terms of, I just wanted to give you an overview of LCA. So what we will do is, I have given you the overview. Now Ravi will take over and he will talk about some of the examples from transport sector. And together with Ravi's stuff and my stuff together, we will take the question answer at the end. So, so let's listen to Ravi as well. Meanwhile, if you have any questions, do put it on the chat box. So if there is something questions which I can answer over the chat itself, I'll do that. Or then we can, we'll take the questions, whatever is there towards the end after Ravi is done. So once that question answer is done, we will have Mr. Samadar joining us around 6:30 to talk about like hydrogen as a fuel. Then we'll start from after this presentation. We'll gradually we'll get into transportation with Ravi, and then we will get into fuels with Dr. Samadar, first with hydrogen, which was not part of our project. And then tomorrow, first Rajashri will go detail on what we have done as part of our project. So again, thank you for joining, and I continue. Mine was just a kind of a very overview. As I said, we'll have a bigger version of this, around 12-week worth of material we'll post on the project website, which will be available. But after this, from Ravi's presentation onwards, it will be more interesting to you because that you will see more application. Mine was more of a theory, isn't it? So Ravi, if you're ready, you can share the screen and I can stop talking.
Yes, sir.
Yeah.
So good evening to one and all. So I hope I am audible. Yes. Yes, sir. So now we'll be, it's like I can, so I guess the screen is also visible.
Yeah, we can see that.
Yes, yes. So let's go into the application part of the life cycle assessment in transportation sector with a vibrant introduction that you have on the life cycle assessment. So I'll just go on discussing few reports which are already available and few works that we have compiled in the life cycle assessment in transportation sector. So I'm Dr. Chela Venkat Ravishankar. So I done my PhD from IIT Kharagpur and Cotton University. So currently I'm an assistant professor in Department of Civil Engineering and Vijaya College of Engineering, Andhra Pradesh. So moving on to the key component, why we are to do this particular life cycle assessment, why there is a climate emergency, environmental awareness that is going on. And we have been seeing that there is an increment in the temperature levels. And in the COP26, we have been promising that we'll not increase our levels by 0.1 degree or 0.2 degree at a global level. So if you wish to reduce that particular component to below our side, we have to do many things at the grassroots level. And as a country, India, our government has already promised both in the Paris Agreement as well as the COP26 will go with 30 to 35% reduction compared to the 2005 level by 2030. We'll promise net zero emissions, and then we have promised almost that we'll increase our renewable energy systems. So with a big picture of this particular one, let's move and look in why as a country we have to do this particular. So India is one of the countries which has first, it's like already we are in the first now with the population. So since 2002 population census is not yet released out, we can see the comparison, the way we are shifting from rural areas to the urban areas. So as we are shifting from rural areas to the urban areas, we can see more and more amount of economic standards being increased, the living styles being variated, and we are very much constrained to ourselves that we'll use our individual transport system compared to the public transport system. We'll see in the upcoming slides. So with the big picture of the population sector, let's move and understand what is our greenhouse gas emission, the transportation component. In an economic sector base wise, if you see, 42% comes from the industries and 22%, the third largest one is the transportation sector. So within the transportation sector, if you see 40% is coming from the road transport, which is typically by personal cars uses, and 34% is from the freight transport. So overall 74% is being contributed from the road transport. and rail, ship, and aviation, all this contribute to the rest components. So since we are increasing the carbon dioxide levels, so greenhouse gas emission levels, so what can we do from our side is the biggest question. So Professor Brajesh has already spoken on the overshoot day. You can see in the year 2023, what is the critical overshoot day for the different countries has been presented over here. But interesting point that we have to observe is in the Earth overshoot day 2020, COVID year has given more amount of replenishment for the Mother Earth. So what exactly we are trying to look in? If we see this particular countries, US is comparatively having very, it's like 5 times below population, more than 10 times below population compared to India. And it is consuming almost 5 times that we consume from a single Earth. And India, which is almost having the first 141 billion population, we are consuming at a rate of 0.7 per capita. Now assume if India starts consuming in this particular direction, like 5 Earths that how US is consuming, and the migrations that we are having, and assume the US population is increasing. So we have only one Earth and we have to compel with that particular one. So it's very, very important for us to start understanding how we'll reduce our consumption rates in each and every sector, and transportation sector plays a very, very major role. So this sector shows that the transport emissions from the transport, and you can see from 2000 onwards, the emissions are increasing and increasing. And it is in the year 2020 when we have COVID, there is a drastic decrement and we are again increasing. And our target at 2030 is to reduce to this particular level. So our net zero emissions should come down. So what has really happened in the 2020? Why we have reduced it? It's like typically we have started reducing our transportation systems. Industries have been shuttered down. So can we really reach to that particular state? No. So we have to go on living. So what is best can be done? How do we approach our systems? That is where the systems called decarbonization has come into the picture. So in the passenger transport activities specific to the Indian mode, if you just look on, it's like the two-wheelers as well as the cars, buses have been slowly increasing from the 2000 to 2020. And it is almost a threefold increment that we are seeing in the year 2020. And it is expected to increase more and more in the upcoming years. So the public transport is a very, very critical component, and freight transport is also in the same mode. Although in the year 2020, it has reduced, but slowly in the year 2021, 2022 is again increasing. And similarly, that tank to wheel carbon dioxide emissions within the Indian scenario, if you are seeing, the comparison has been given with respect to light commercial vehicle, medium freight, heavy freight truck, and for the cars, two-wheelers, buses, air and rail. So typically the cars, if you just see in the 2020, it has been almost a 5-fold or 6-fold increase is being looked in. So we are continuously contributing to the huge amount of emissions in the Indian scenario itself. So how do we come up? What do we make in transferring all these particular components? What are the mechanisms that we have to do to reduce our emissions to achieve our net zero goals? So life cycle assessment is one such tool which gives us an understanding of different scenarios where we'll have to look into the product development, strategic planning, public policy making. So these are all the strategies when we are trying to make by doing different mechanisms, different policies. So it has to be supported with proper quantified values. So life cycle is one such tool which gives us a proper quantified tool to take or do well. It's a good decision making. So prior once when we are going to understand it, we should have a proper system boundary. So if we just see the top blue one, which is showing extraction to the combustion, where extraction of the crude oil, transportation, refining, again it is transported and distributed, which we are using both petrol as well as diesel modes. And now we are trying to shift towards different alternative fuels, which are bio-based and renewable based. And for those, we are producing a crops. From there, the main function of the particular crop is for the food. And the secondary function that we can use is for the vehicular activities as a fuel. So land use, then there is a cultivation step, then transportation, conversion of this particular one to the fuel, transportation and distribution as a component. So each and every component of the life cycle has to be taken into the consideration. And at each step, we'll see the individual component where the raw materials need to be produced. Inventories have to be developed over here for the raw materials, for the emissions. So as a country in India, we are lacking the data sets. So this project which we are trying to do is to develop different data sets specific to the Indian context. Across the globe, many research laboratories are working in development of this particular inventories. And the inventories have to be developed for the each step: oil and gas production, transportation, crude refining, in diesel transport, then utilization, and then emissions. So when we use this particular one from the well, that means extraction till the fuel pump, it is called well to pump. When you are using it well from your direct vehicle, it is called well to wheel. And from the pump to the vehicle, when you are using it, is called pump to vehicle. These are the different scenarios where different researchers have used, and they started modeling at the individual components, and they started analyzing this particular one for strategic development. So, and typically when we see the life cycle of a vehicle technology, what we are having. So first we have feedstock, which is the fuel cycle, the feedstock production, feedstock transportation, fuel production and distribution. In the previous slides, we have looked into the fuel cycle. Similarly, we have a vehicle cycle. The raw materials that are to be required for assembling a vehicle or manufacturing a vehicle will be extracted, and they're produced, and then the raw materials are transported, and finally to a vehicle production unit will be getting, and the vehicle assembly will be there, where both combinedly will be used for the vehicle component. And the once the vehicle is there, we'll add fuel to it and use that particular vehicle. That's the utilization phase. And after its design life period, it will be a disposal. So all the steps have to be considered very carefully. We have to develop data set for the each and every component. So data inventory or the databases are the key and heart of the life cycle assessment. So next, so let's look on what would be the approaches that are there for coming to a net zero emission by 2050 in the Indian scenario. So taking an example of the rail focused scenario, if you can look in from the 2015, we are continuously increasing our emissions, and it is expected with the current policies that we are having, by the 2050 we'll have 1,170 metric tons of air. So if we wish to reduce them carefully, there are multiple approaches that we have to implement, where the different shifts that you are seeing is the innovative urban planning, modal shift, improved efficiency, electrification, alternative fuels. So it is not one single strategy that will bring you out into the net zero emissions that we wish to achieve. So if you just take the urban scenario, we have multiple routes which are coming up. So if you were to go with the shortest possible route, so we are developing different freeways, different alternative ways. We are using GPS systems for the innovative urban planning. So for this particular case, you have to do, we can do an LCA work over here by considering different alternative vehicle types, alternative vehicle routes, capacities that we have with the passenger vehicles, that means the type of the road that you have, and then you model it for the amount of travel that we will be doing as a functional unit, so that we can have a reduction of 205 metric tons per year. So the contribution which is going to get. And the modal shift. In the modal shift, the transportation system has to be completely changed. We, as an Indian scenario, we have mixed transportation system. We use two-wheeler, three-wheeler, four-wheeler, then road transport, rail transport, especially in the freight. India is one of the key critical components of freight transport by railways. So what is a passenger mechanism system? If we move from individual transportation system to the public transportation system, has to be modeled, and doing that particular analysis, we can have a reduction of 550 metric tons from here to the lower, and improved efficiency. It comes with the environmental standards of the vehicles that we are using, and typically the year life is how we are disposing this particular one. Typically in a surveys, it has been looked at almost all we use 15-year-old vehicles still we are using. It's like 30 to 40% of the vehicles are above 15 years old, which contributes to the huge amount of emissions that are coming up. So if we can improve our efficiency over there, it will be very, very good component. And electrification is one critical component which is seen in all the LCA studies. Electricity mix plays a very, 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 very major role. India is with a coal mix, and currently we have 57% of our mix with the coal, whereas in the Norway, if you just look in, it has 95% of hydroelectric power mix. So the shift that we try to make in this particular electric mix will reduce the emission. And very important component is the alternative fuels, which we are trying to look up in our system and in the project now, where we will try to shift from the traditional ones like petrol and diesel towards the ethanol all based ones, biodiesel based ones, CNG based alternative vehicles. So this gives a very broad picture that where are the strategies that are to be developed, where LCA can be integrated into this particular each and every component to enhance this strategic planning and the decision making. The same scenario is being shown for the road focused scenario. So the previous one is the rail focused scenario, whereas in the road focused scenario, the innovative urban planning with the same component, whereas in the modal shift is only 40 metric tons per the year it is coming, and the improved efficiency and the electrification is the critical component. Why the electrification plays a very major role here is our current policies are pushing towards the electric vehicles. The increment in the electric vehicle usage is directly linked to the electricity component. So alternatively, we have to move towards the alternative fuels as well as the alternative energy mixes like renewable from solar, from wind and hydro power. So that will reduce our emissions by 2050. So now we'll just look into the greenhouse gas emissions typically based on the size passenger. So where we have gasoline is one critical component, diesel, natural biogas, 3 linked with the biofuels. So it's a mix that we are trying to use. And then plug-in hybrid vehicle, which is now currently using this particular one, which is very famous and increasing. And battery electric vehicle with 20-30-47 grid mix is one scenario we have been using. And battery electric vehicles with renewable electricity, fuel cell. This is a hydrogen mix component with 2030 to 2047, which they are trying to look at. And the comparison is being made between the different fuel types. So in all the scenarios where we have gasoline, diesel, and natural gas, so the emissions are very, very high. And similarly, when in the scenario of biogas, we have methane generation production, which is contributing to the incremental over here. So the shaded portion for 20-year global warming potential from the methane is also considered, whereas in the fuel energy vehicle with hydrogen mix, it is reducing. And in all the scenarios, we can see when we shift completely to the electric vehicle and the fuel cell, there is huge amount of reduction in the greenhouse gas emissions. So the transformation, how we are going to make this particular one, again, we have to look into the different vehicle types, different systems that how people are utilizing it, electricity mixes that are going to come into the picture, the maintenance components have to be taken into the consideration in reducing our emissions. But more very critical component that we have to understand from this particular component is the fuel consumption and fuel to electricity production ratio. Those two are the major components which are producing almost are contributing almost all to the 70 to 80% of our emissions. So that's their need that we shift towards the alternative fuels as well as our electricity mixes. So then if we can look at the life cycle emissions for 40-ton tractor trailer in 2021 and 2030 scenario, how we can shift towards that particular one. Certainly in the each and every component and we are moving when we are trying to reduce our systems. So in the 2021 scenario, we have almost 1200, whereas in the 2030 scenario, the diesel and biofuel has to be reduced. The basic reason that the report explains over here for the reduction of all these components is the efficiency increment and the maintenance component that we are using. So, so that's one important consideration we have to look in. And this shows for an average medium-sized gasoline internal combustion engine versus the electric vehicle components for the different countries, the 2021 scenario and 2030 scenario. So obviously, when we try to move or shift our electricity production system, electricity mix systems, the alternative fuel increments, the maintenance activities, it is expected that we can reduce in each and every country scenario. It's like typically with the current policies that are having, the Europe can reduce almost threefold, whereas India, we are able to reduce from like 1/4 of our emissions are being reduced. So we have to, the major reason for this particular one is that we have to shift towards the renewable fuel energy mixes as well as the alternative fuels. So this comparison is typically between the current policies that our countries are having, whereas the Paris Agreement, which is compatible to this particular one. So with the big picture scenario that is there, so at researcher level, at a small research level at the laboratories, what best can be done. So there is a few case studies which our laboratory has worked on. So where a compared to life cycle assessment for the microalgae production for carbon dioxide sequencing from flue gas has been investigated. So where they have used the riceway pond for the cultivation, and you can see here, this is the system boundary that is being considered, where each and every component that is being used will be taken, like tap water, electricity there, from the different pumps, then flue gas generators, and the chemicals that are being used, water evaporation from this cultivation pond is also calculated. So even the minute details that we are considered that are being reported in our project has to be taken care. So because a small component, a product which is may generate a methane gas, may contribute a lot to our life cycle system for the in the global warming potential category. So, and one more example that we have is environmental impact analysis of oligous yeast-based biodiesel and biocrude production from life cycle assessment. Here, we can see in the system boundary that cultivation of yeast is done in the bioreactor and the yeast broth is harvested, and using transesterification process, they have developed the biodiesel, and from the hydrothermal carbonation, they get the waste streams out. So in each process, we have to develop a unit, consider each one as a unit operation. What are the inputs and outputs have to be calculated. So that's the database that we are trying to develop. And as in the Indian scenario, we are working critically on development of the databases. So this is very, very important scenario where each and every researcher, each and every laboratory has to come hand in hand and develop this base data sets, which will help in doing the life cycle assessment and further in the development of our strategies. So in the harvesting scenario, you will be considering electricity and cistern, and in the cell disruption, electricity. And in the transesterification, we have different chemicals being used and electricity. So you can see at each and every step, we have electricity as one of the major components. And in the emissions side, you will be seeing carbon dioxide production, then solid waste, which are being produced. And so all this has to be captured. And once we develop the data set, we have models for doing this. For example, in the transportation, we have GREET model, and there are generic models like SIMAPRO, OpenLCA, Gabi, so which all help us in putting all our data. And it gives very nice understanding, like the bar screens which you are seeing for each scenario that is developed, what is the hotspot that is coming out will be identified. So based on the identified hotspots, we'll start developing the alternatives. Once we have developed the alternatives, reconduct the LCA once again, and then look at the different scenarios, considering the current scenario as business as usual, and we can develop policies. So then until now, we have seen from the vehicle side. Now let us look at from the payment side. So this is a small example that has done the life cycle assessment of railway track substructures, comparison of ballast and ballastless railway tracks. So typically in the Indian scenario, when the railway tracks, we'll see that there have been railway lines are laid with huge amount of natural aggregate. So if we shift from that particular ballast mode to the ballasted railway tracks where we have concrete components, what would be the variation that we are getting? So this is the infrastructure development that we have to look at. So here the different models, the production is one component where the excavation of raw materials, transportation, manufacturing, and the finished products will come into the production. And then the construction activities of that particular ballast railway tracks have to be taken. And then the maintenance component. So typically in a year, we'll see there, it's like when we are traveling in a rail transport, we'll be seeing people always maintaining that particular one. So how much amount of electricity is being used in that particular, how many amount of water are being used. So we have to calculate each and every component. And critically in the end of life, how we are dismantling it, how they are being discarded, can we bring them back to our product? It's like into our circular chain. Is it possible to recycle that particular one? Is a critical component. But in the current study, the others have just verified the variation between in the ballast and non-ballast track. So where Balfour Beatty embedded slab track is one component that has been used, and RADA model is the second it's like ballastless railway track they have seen. And critically, the ballast has been giving in the 50 years, 75 years, and 100 years, there is a reduction. And climate change, it is the lowest one. But when we shift towards the other two models, although you see a high increment compared to the ballast railway track, the conclusion that has been made as the RADA will be very, very good one, because over a period of time, that is in the service life of 50, 75, and 100 years, you can see at 100 years life cycle, there is a reduction in the RADA mode. That means the operation and maintenance is playing a very, very major role. In the ballast, you have to replace your natural materials regularly at a period of 30 to 40 years, whereas the life cycle, that the small repairs will be coming in the radar model. So the key conclusion that is taken, that you have to see a long period of time where your emissions will slowly get reduced with improved efficiency. See, so now compiling all these particular components in the interest of the time, let's look at the different common topics that we have. So in the LCA topics in the transportation, we have payments, maintenance, vehicle, fuel, modal choices, and infrastructure component. And in this particular slide, I'm presenting you for the vehicle component. So what are the considerations that you can do? Vehicle production manufacturing, fuel type and efficiency, what are the different emission control, BS4 norms, BS6 norm, Indian norms, which you are getting now, and different driving conditions of the vehicle. It's like more the time, if we can see the braking systems that we are having, the infrastructure component, that due to the breakers that we have over here, the driving conditions vary. The brake and tire wear is one critical component that we have to look in for the vehicle components variation, repairs and fluid changes, recycling and end of life. So these are the various considerations that come in the vehicle mode, the vehicle cycle that we are looking in. And the softwares that are available is the GREET software. So in our project, we are trying to develop it's like data set which will be fitting into the GREET model. And these are the different topics that are there for the payment components. And I'll be moving on to the payment model. So where we have considered different raw materials. So India is known for doing a lot of construction activities. Our infrastructure is being increased, and recently in the union budget, we have seen 15,000 crore or budget has been placed for developing of the infrastructure, where the roads play a very, very major role. And 40% of our cities are covered with typically with our asphalt payments. And what are the different materials that you'll be using plays a very, very major role. Do you lay a layer every time? It's like after every 10 years, will you lay a layer, or will you do a full depth reclamation over there? That is the in situ recyclation of the payment and immediately pave that particular one. So the different alternatives have to be looked in the raw material side and the construction phases. So what are the different methods for construction? It's very simple. We have the bituminous flexible payment and rigid payment. How variations have to be taken care, we have to look in. And removed materials is one which I'm speaking on. Like recycling that same material will reduce huge amount of impacts in our upstream sites, where the raw material extraction, then in the product manufacturing components. So we have Palette and EcoCore are the two relevant softwares which are being used in the transportation sector over here. So these are a few topics that are available in that particular arena. And then the next component is the fuels, which is the heart and core of any vehicle. So for the transportation, this is one which is not seen, but which is the internal component, just like our blood, which is flowing on, and for functioning of our heart. So the feedstock, it's like when we are trying to look at the traditional ones, like crude oil extraction has to be done, petrol and diesel are being used, and diesel is one of the key polluting components in our system. So we should find an alternative to this particular one. So we are coming with second generation biofuels, third generation biofuel, CNG is coming in, then we are trying to go for hydrogen fuels now. So we have to see the production of this particular one, processing, in distribution, and the different usages in the vehicle components. So the relevant softwares that are being used are the GREET and FEC, fuel and emission calculators. And these are the few topics that are available with this particular system. Then what is the big take-home message from this particular session that we are having? So LCA is one of the components which is growing its interest in the Indian scenario. So this gives a big picture scenario at the global level, how we have to manage our greenhouse gas emission and many other impact categories like carcinogens, ozone layer depletion, mineral depletion, water depletion, human health. So, but actually at an Indian scenario, do we have necessary data sets to do all these particular components? Yes, we are improving our data sets in the past 15 years, but on the side, no, because we have to do a lot of data sets have to be developed, right? Because India is a diversified country where all the 6 directions, it's like 5 to 6 directions which we have. The modes are different, the way people lifestyles are different, economic standards are different. So individual specific data sets have to be developed where we get diversification and unification in developing a individual strategy. And the critical areas of application, as we have seen in the road and rail transport modes for the India, innovative urban planning, alternative fuels, modal shift, policy development, electrification, and documentation and communication are the key critical areas of application which we have to look into this particular one. And similarly, the development of the life cycle inventory systems is a very, very big area of research that is needed, and which is the need of the hour for the Indian scenario. So the basic project which we are working on with the ITF is critically in this particular area in the development of the data sets. So once this is there, we have to go on to the impact assessment. So typically we are in the impact assessment, we see there are different models which are specific to few countries like Europe and for the global. And we have to develop few characterization models specific to the Indian scenario and develop our Indian specific normalization factors and the weighting factors. And finally, we have the interpretation which has to be done. So systematic methodology, how do we assess this particular one? How do we develop the databases for this components has to be understood. So that is where in the tomorrow's session, you will be seeing the data inventory development for the emissions coming from the different vehicles. And on the third day, you'll be looking at from the payment side and the alternative fuel side, what would be the systematic development of for analyzing all this from a life cycle approach. And the same one, it's a conclusion that's the connection that we have from the previous session to this one. Are we problem solving or problem shifting? Yes. When we have shifted from diesel to electric vehicle, we have shifted the problem. We have solved the problem at individual level, whereas we have created a new problem. So it has been problem shifted in the second scenario. But as an engineer, we are never shifting this particular one. We have to try solve some of the component over here where we shift towards the alternative energy mixes, that is the renewable. And similarly, in our vehicle component also, the fuel component also, we are going for the alternative fuels. So we should start thinking, and do a lot of analysis in our component to do more amount of problem solving rather than problem shifting. So thank you.
Okay, Ravi, nice presentation. We have quite a few questions there. Let's try to go over one by one. We can start and we both can answer them based on. Let's see. Thank you. My question is, let's start from the bottom. There is a question from Vinod Yadav. This question is, what kind of challenges or difficulties you find during the comparison of various LCA studies? So when you are comparing 2 or 3 different papers of similar kind of work, I think that's what probably he's referring to. What kind of challenges or difficulties do we face? So Ravi, you want to talk about that? I can add to that after that. I'll let you answer it first.
Yes, sir. So when we are trying to compare 2 studies, the first problem that we get is the system boundary that they have, as well as the functional unit. So when we analyze or compare anyone, we'll try to see a similar functional unit studies, and then we'll try to identify what are the different system boundaries, like within the system boundary, whether all the components have been included. So each unit process will be considering. That's the first one. Second is the inventory database that they have used. So is it a global inventory database or a country specific database? So, and there'll be huge amount of data missing in this particular component. So where we have to get those from either from the person who has done that particular work or from the generic sources which you are going to look in. The third component when we are comparing the problem is the model method that they're using for the impact assessment. So few people will use recipe method, few people use CML method. So that's where I've been explaining that the normalization has to come into the picture in understanding the anomalies or the errors that are coming among these particular components. And similarly, the analysis which has been done from one mode might be good, and then if you do it in the other mode, few problems may arise in that particular one. So the results may vary. So at most, care has to be taken in identifying the functional unit, identifying the inventory databases, system boundaries that are being used, impact assessment methodologies is, and what are their scenarios that they are considering to their policies to that specific country. If it is generalized, we have to clusterize it into the one. If it is specific to the country, what is the policy that they're having there? So this will help in giving a very good comparison between the studies.
Okay, so it's okay. I think that's pretty much good. And then there was one question is from Raj Shekhar. He started, please specify Indian specific emission factors for fuels and also with respect to type of vehicle. I think that that information, Rajshekhar, you will get tomorrow as well when Rajashri will present the data that he has collected, that we have collected as part of this project. So Rajashri, do you want to talk about that a little bit today, or should we wait it for tomorrow?
I can wait for tomorrow, sir.
Okay, okay, so that's good. Now, Ishan Bhaduri says, Ravi sir, what are the vehicle LCA tool that which can be applied in the Indian context? Vehicle LCA tool? Are you talking about various LCA tool? Like, can you elaborate that question, Ishan, if you're there in the audience? Ishan Bhaduri?
Hello, sir, am I audible?
Yeah, you are.
Yeah. Thank you, sir. I was trying to ask that generally we use GREET model to understand the impact for electric vehicles vis-a-vis IC vehicles. So mainly the GREET model is based in the USA context, all those factors that we use generally. But if we're trying to apply that model in the Indian context, so we need to tune it according to that. So I was trying to understand that what can be like, is there any other tool or software like GREET which can be applied in an easier way in the Indian context? Or is there some other way? That was I was trying to understand.
Okay. So Ravi, you want to talk about that first, or you want me to do that? You are mute.
Sir, you can do that particular one, sir.
Okay. So in terms of, as part of our project as well, that ITF project that we have, one of the reasons that they have given this project to us is essentially to answer the question that Ishan, you are raising, like how to get the India specific data. So the data that we are producing as part of this particular project, which Rajashri will be sharing with you all tomorrow. There we have tried to collect India specific data. There is always some limitations in terms of availability of India specific data, but whatever was available, we have collated it together. And then we are trying to make it in the same format in which the data is available in the GREET model. So our data will get merged with the GREET model in subsequent, like a subsequent time, you can say in a year or so, or within a year or 2 years, it will be there. So GREET model will have then not only the US specific data, it will also have the Indian data. Other thing that you can do if you want to look at, like if you want to do a like a kind of a basic LCA, you can always go back to the doing LCA using SIMA Pro or Gabi and all those different softwares, which do has EcoInvent database, which has certain Indian specific database as well, or you collect your own primary data and do LCA based on that. But yes, to help with the GREET model to be more realistic from the Indian point of view, our results will be incorporated. So, and then you will get some of those data tomorrow when Rajashri will present.
Okay, sir. Thank you. Thank you. I got it. I'm looking forward to tomorrow's session.
Yeah. Then Rajesh Chaudhary, what is that? My internet connection was fluctuating. I get the recording will be available. As I mentioned in the beginning, the recording of all the 3 days, along with the program details and the reading material, everything will be available on ITF OECD website, and we will also share it, the link of that with all the people who have registered for this workshop. So you will get the link for it. It may take a couple of weeks before you get it, but you will get that. Okay. Now, let's where we can get these PPTs. Again, you will get it from the ITF website. Pankaj Gadhavi, you will get that. Abhishek has a question that whether it is advisable to ignore biogenic carbon emissions to tackle climate change, global warming. So Abhishek, it is personally, I think it's not, but that's the protocol right now. It's basically what, as you know, the biogenic is, we are kind of assuming that since they are coming from the natural processes and it will get captured by our by the trees and like by the biomass again, it will go use back into the system, come back into the system. So it is not actually going into CO2 emission. So that part is okay. But even to do all those, say for example, you're doing biodiesel, like all those bio-based fuel, and to generate that bio-based fuel, the raw material, you're doing a lot of agricultural activity, you're using a lot of machineries, you're using fertilizers, you're using water. So those also has carbon footprint, isn't it? So those so part of that, in my view, should be incorporated. But as for now, as per the protocol, as per the practice, we are not doing it. We are not including it. So I'm with you on that. Whether it's advisable. Yes, but also no, both is there. So I guess probably that's what you are also thinking. Okay, so please share the LCA database links. Okay, we'll talk about Rajshekhar, as I mentioned earlier, that we are going to produce there is a YouTube video course, 8-week course on LCA lifecycle analysis as part of the SWAYAM platform. NPTEL platform. So that course does have details of many of I did a very quick overview of basic how the LCA is done, but that has a lot of details. It is available on YouTube. You can see that. But we are also going to do a specific for this particular project. We'll take like a small LCA course focused on transportation, around 10 hours worth of video we'll prepare, and Rajshekhar, you will get a link to that. Which you will find there. In terms of database, of course, EcoInvent is there, which you can use, which everybody uses pretty much around the world. Let's see, Rakesh Chaudhary, okay, internet fluctuating, the other way is done. Ishan Bhaduri also. Hema has a question is, please clarify how LCA can be integrated in policy making process at different levels to accomplish the decarbonization goal. So Ravi, you take it.
Yes, sir. Critically, if we just see the current scenario, which you have business as usual, where we are trying to use a diesel as well as a petrol engine. Now, if we are trying to do a shift, for example, we are going for electric vehicles as well as hydrogen fuel. So what would be the emission reduction that we are having? What policies have to be changed in developing this particular strategy? So we have different components. One is the infrastructure development. Second is the urban planning we have. And third is the alternative fuel. All this are modeled in different scenarios. Business as usual, where we have a petrol as well as a diesel. And the next scenario is using only diesel plus 50% of the biofuel. And different scenarios we'll be developing. So each scenario we'll develop a data set, and we will calculate our impact emissions. So in whichever scenario we are getting the reductions, and we develop a ranking, and we'll identify the hotspots. Once the hotspots are identified, so the critical hotspots, will perform a sensitivity analysis to see what would be their impact in different conditions. So all these outputs, once we have arrived with different results, so then we'll look at, yes, this is the best scenario when it is implemented in a certain condition, and these strategies can be implemented. So once this results arrived, we'll circulate this with the academicians, researchers across the country for the decisions and the opinions, and we come up with the recommendations, and finally a policy will be drafted. So the LCA is the base area where, with different alternatives, what is the value of the greenhouse emission or different impacts categories will be quantified. Instead of qualitative judgment, this will give us a quantitative value, so that a policy directive can be developed, or a better decision making can be done.
Okay. Then there is a question from Varaprasad. Varaprasad, can you unmute and ask that question? Because I was a bit not sure what exactly you are asking there. If you are there, Vara. Or Ravi, you can see that question as well. If you, I was a bit. Yeah,
my question is, there was one slide talking about the electrification of transportation sector. So if the electricity is coming from the thermal power plants, then there is also fuel consumption there from the coal, right? So what is the net reduction in CO2 from if we convert from conventional fuels to the electrical vehicles?
It's like the question is like, if we are converting from biofuels, it's like the regular transportation fuels to the electric vehicles, the electricity component which we are getting from the thermal side is also increasing. Yes, that's what the picture which we are trying to show, from diesel movement to the electricity movement, the problem shifting is being done. So there we have to work on our electricity mix, where the India in the year 2016 to 18 we have 69% of the coal. Now we have shifted to the 57% of the thermal power component, and slowly we have to increase our renewable components. For example, if we see the Norway scenario, where they have almost 90 to 95% of the hydroelectric power plants. So we can't exactly replicate that particular scenario given the conditions of the Indian context that we have. But slowly, based on our regional conditions, we can move towards solar, we can move towards wind, we can do more hydroelectric power, we can, so slowly shifting towards that particular alternative components, we can reduce the impact on our electric vehicles. That's the scenario in one slide where I am showing the electricity mix has to be changed. That's the current policy which we are having with 59% of the thermal power. So shift it towards the 45% to coal, or come to a level of where we'll use only 30% thermal power plant, 100% our it's like the impact can get reduced. So the overall impact that we are targeting by 2050, where we'll reduce 70% of the emissions, facing that particular one, we try to model the components.
There was one question from Dilip Khantiwada. I think when we have the next presentation on hydrogen, so I think that may get discussed there as well. So, but he was talking about hydrogen cars and buses in 2030, 2050. Like hydrogen versus electricity as a transport fuel. Does they compete? Like what is 2J biofuel together with CCS? The source of electricity derived from renewables or bus traffic transit systems in Indian cities, bicycling behavior change. Does this make sense? So basically, he's trying to compare. I think Dilip has to leave, so he's not there in the audience. He just sent me a message that he had to leave. So basically, like I think we can. It's more on, yeah, of course, bicycle behavior. If you people use bicycle more, that's good. Always having public transport, bus rapid transit system is always going to help as we get away from individual cars and all that. Those things are definitely there. But how they compare, like whether they will compete with each other, hydrogen versus electricity, I don't know right now, unless Ravi, you have some insight on that. I haven't looked into this aspect so far.
Yes, sir. Sir, typically we have one document which I can share with everyone, that Climate Action Tracker, Decarbonizing the Indian Transport Sector Pathways and Policies, which has been released in the year 2020. Mm-hmm. So there they're trying to look various effective models across the world. So for example, the Copenhagen model, where they're trying to shift towards more number of bicycles system. So and similarly, they're trying to look at how EV systems and tax benefits that they're getting. So different policies are there's a successful policies which are being implemented across different countries. So each policy has to be taken, and we have to look into the maturity of this particular system, because whether will it be really can be implementable. That means the tailor making to our Indian scenario, and post that particular, we have to see the impact on the schemes that we develop. Because now, if we currently see the EV is being budged out as one of the bigger components, and we can see a huge amount of promotion coming out, like by 2026, we wish to have 30% of the vehicles completely replaced with electric vehicles. But what about the infrastructure development? So what about the charging points? So how do we implement it? How do the infrastructure needs to be developed is also to be looked in. Yes, this comparison requires huge amount of studies, and that report, which I am telling out, gives us a very good understanding on how the behavioral changes are being taken into consideration, how shift towards different vehicles, shift towards different alternatives should be considered in the policy making has been well defined, sir.
Okay. We have, I think there is only one question left, or there is a new question there as well, or let's see. There is a new question there, but there are a couple of questions. But before, I think Joydeepa had a question. Can Joydeepa, you can unmute and ask that question? What exactly, like, what is the scope of integrating LCA with environmental impact?
Sir, I can answer that one, sir.
Yeah, go ahead.
So basically, can we integrate LCA and environmental impact assessment as two systems? No, why? Because LCA looks at a global level, whereas environmental impact assessment looks at a regional level. So LCA looks at the complete supply chain which you are having from raw material extraction to the disposal scenario, and it identifies the different hotspots. For example, if we see that in the manufacturing unit, X process is the hotspot, it will be identified by life cycle analysis. So for the same point, we have to do a in detail life cycle environmental impact assessment, where we have to consider how much amount of flora is missing, how much amount of fauna is being disturbed. So what are the health impacts that will be coming over there? So LCA is one tool which gives a global picture, whereas it has to be connected with substance risk assessment, then environmental impact assessment, and we have to consider that individual tools which will support the decision making of the LCA in detail. So the scope can be broader one, but LCA and EIA are two different tools which will be required for understanding the impact assessment.